Okay, so we are to the last lesson in Unit 4. This is Unit 4, Lesson 6, Similarity Transformations. So I'm going to read this definition. I'm going to explain what this definition actually means. So a dilation, what we covered in the last lesson, is a transformation that preserves shape but not size. So a dilation this is an example of a dilation. I shrunk the page, okay? It's the same shape, just a different size. So dilation is what we call a non-rigid motion, meaning it changes the size of our object, our figure. So a similarity transformation is either just a dilation, or we can do dilations with rotations, with reflections, with translations. Those are all possible. So when we do these dilations, it creates two figures that are called similar figures. And we will get into similarity later this year. And we'll talk about that. So similar figures do have the same shape, but not necessarily the same size. And these transformations, they preserve length and angle measure if they are congruence transformations. That means everything stays the same. But in a similarity transformation, a dilation, it only preserves the angle measures. So the shape stays the same. The angle measures preserve the shape. The side lengths preserve the sides. So if I make a dilation, that changes the side lengths, but not the angle measures. That preserves the shape of our figure. So an example of a similarity transformation is a translation and a dilation, both happening. So I'm going to just write out the points first. So I'm going to do A, -4, +1. B is -2, +2. And then C is -2, +1. And I'm going to graph these. And the thing here, I am sorry for this, but it goes up by 2s. So we've just got to be careful of how we're graphing this. And there's kind of a reason I made it so small, but it does make it a little bit harder to graph. So the first transformation I'm going to make is I'm going to translate this right 5 and up 1. So A becomes A prime, and that becomes +5. This becomes 1, 2. Point B, this becomes 3, 3. Point C becomes 3, 2. So I'm going to graph this translation. 1, 2. 3, 3. 3, 2. So this is my image. A prime, B prime, C prime. That's all of my images, or the image of all my points after that translation. Then, I'm going to use green for the next one. My dilation, all that does from my translation takes every single point, every single value, multiplies it by 2. So this becomes the point 2, 4. B becomes the point 6, 6. Okay? And then C becomes the point 6, 4. So we're going to see what happens here. So I've got the point 2, 4, 6, 6, and then 6, 4. Okay, so this is A double prime, B double prime, C double prime. And those apostrophes just mean how many transformations I've done. So essentially, I moved it right 5, up 1, and then I doubled all the side lengths. So I doubled the distance from 0 for all the values. So that's all a similarity transformation is. It's just a composition that involves a dilation. Okay? So, in the next one, we're mapping Pqrs, the big shape, to the small shape. Okay? So a couple things happened here. So what I'm going to do to figure this out is I'm going to do the points of P, Q, R, and S. I'm going to literally write them out. P was -6, +1, 2, 3. -6, +3. Q was -3, +3. R was 0, -1, 2, 3. And then S was the point -6, -1, 2, 3. That got translated to, maybe I should have done green for or blue for this, but translated to X, Y, and Z. Okay, so it got translated to W, X, Y, Z, my bad. W, X, Y, Z. So W is the point 2, 1. Okay, X is the point 1, 1. Y is the point 0, -1. And then Z is the point 2, -1. So we should notice some things that are going on here. One thing I'm going to think to notice is that one of the transformations was a reflection over the y-axis, right? Because it looks like we flipped this shape over the y-axis. So that's one of the transformations. And then I'd say our second transformation is some sort of dilation, but our dilation here, it took a bigger figure, made it a smaller figure. And if we look at it, it's like I divided all of these points from Pqrs, divided all of them by 3. Okay? Divided all of them by 3. So this would be a dilation by 1/3 because I am making my shape smaller to produce an image. Made my shape smaller. That's why it's dilation by a scale factor of 1/3, not 3. Okay? So our last example, problem 3 here. Call it example 3, but I'd like you to try to figure out what was happening in this similarity transformation. 2 transformations happened. Okay? If you want to use 1 point, use 1 point. But sometimes it helps to write out all the points to see a pattern. So try this. Try to see what happens to go from DEFG to STUV. So again, we went from this shape to a smaller shape. So pause the video, try this one out, and then check your solution with me. Okay, so for this final example, I really only used 2 points to see my pattern. From this, I can tell from the beginning that this was some sort of rotation. It looks kind of like a reflection, but if you look closely, it's a rotation 180 degrees around the origin. So that's the first thing I saw. The second thing I saw was that every value from D to S, E to T, it was like I was dividing by 2. So I knew that was a dilation by a scale factor of 1/2 because I was reducing this shape, this bigger shape, to get the smaller shape. That's why my dilation was a scale factor of 1/2 and not 2, because this was another reduction. So really all this is extending dilations to including them with rotations, reflections, translations. So you're probably ready for the practice. I've got a quizzes ready for you, and then paper practice is sometimes hard. So what I'm going to try and do, instead of you guys graphing things so much in this lesson, you are going to be more describing like we did in these examples, okay? So I'm going to try and include more descriptions of transformations rather than the actual physical graphing, because I know that's hard to do on a sheet of notebook paper.